we'll go ahead and get started. So thank you so much for being here for our webinar about navigating the NetDevOps Lifecycle. We are so happy that you are here with us today. My name is Eden. I'm on the marketing team at Sunset Learning, and our presenter today is Stuart Fieser. He is the president and CEO of Alta3 Research, and he's been in the data and telecommunications industry for the past 35 years. He founded Alta3 Research in 1997, and for the past 23 years, he's dedicated his company to the thorough understanding of complex systems through researching the latest technology and delivering training and consulting services based on the company's research. So we are so happy to have him here presenting with us today. And Stuart, I will hand over the slides to you.
Okay, thanks, Eden. Hello, everyone. Thanks for joining. I'm Stuart Fieser. We are going to cover from planning to practice, navigating the NetDevOps lifecycle. Now, let me go over the agenda real quickly. Initially, what is NetDevOps? And I'll cover the basics of that, specifically on what is DevOps, maybe. Then learn why NetDevOps is needed, why we need to add the net part, why can't the DevOps part just apply? Then when it comes to the NetDevOps lifecycle, there are distinct steps. Business justification, then implementation, and then the operations of it, keeping it all running. And you're probably going to want to add additional features down the road, additional capabilities and things that are possible. And you want to have the opportunity to do that yourself, because not all networks are identical, and the ability to manage features is a pretty big deal. We have a wonderful surprise for you. In case you don't know, there are hands-on labs. This is a labinar. So when we get to that point in the presentation, if you just can't wait to get your hands on some of this stuff, we have that opportunity for you. We'll talk about the upcoming classes then that address these four things. Then we'll finish up with Q&A. So let's get started. So, interesting fact. Way back in the 1800s was the first assembly line. No kidding. And it was Eli Whitney that came up with this. It was unheard of. The idea that these individual parts right here, not all custom made, but all designed to go into whatever the assembly line is making, and it's guaranteed to just fit, so that as stuff goes down the assembly line, when it gets to the other end, it just works. Very cool. Now, the downside of that is these guys are way ahead of us. In the 1800s, what they were doing is ahead of IT. Fortunately, maybe about 10 years ago, we did catch on with an idea called DevOps. And the thinking is, why like this? This makes sense. Why aren't we doing this? Why isn't there an assembly line for what we do, where we handle the development and we handle the operations? We merge those two into a system, and DevOps is created. But the real question now is, well, is there a thing called NetDevOps as well? And the answer is, of course there is, and that's why we're all here. So with that backstory, let's just get into it. What is this DevOps thing? So it's always this infinity symbol that we show, where the first step of our infinity symbol, which is going to draw just like this, is the planning. Planning is just that. Here's what I want to do to the system. Once I've sorted that out, it goes straight into the developers. They start to write the code. Now, the idea is that that code should work. And in networking, not only do you write the code, or in this case, you write the change, but you also have to write the rollback. Keep that in mind. You actually implement the code, and then you actually design what you would have to do to take it back out. The next step then is to build it, which is to build it in a test system so that it replicates exactly what it would look like in the actual production system. Test it. That makes sense, right? Now, look, as soon as we cross over this line, we're going from the dev side to the ops side over here. And the way we do that, our handoff is the release, where we say, here is the release or the new software that's going to run on the operations side. So that's a very big deal. Deploy means, well, hopefully deploy it. and it just works. But if it doesn't work, we want to roll it back really, really fast. Operations means keep it running. Anything that might go wrong, power failures, system failures, a firmware just dies for whatever reason, power goes out. I mean, it could be a lot of things, right? The operations has to deal with that. Then we add monitoring, which is watching what's going on in the system. And we don't stop there. You go through this infinity symbol over and over and over again. That's DevOps. So how does this apply to NetDevOps? Well, the answer is it's almost identical. And that's actually the point of this presentation. Now, before I go into actual NetDevOps, you're going to have to let me go through today's methods, and it'll be in 10 steps. It's going to go fairly quickly because not all of us are necessarily networkers. I am. I suspect most of you are, but some of us may not. So how do we do this now? Do these steps exist now? Well, sure they do. The first step is planning. Now, honestly, I'm the type of a manager that if this is on a beer stained napkin, if you're accurate in what you're telling the staff to do, which on a beer stained napkin is kind of iffy, but the point in planning is to be crystal clear to the code writers what you want. So in this case, looks like we're adding a new firewall appliance. Okay, great. This is oftentimes how it's done, and that would be entered in the change control as we want to do this. The next step then, which is where it gets really ugly, in my opinion, is that I have to go grab all of the adjacent components. So I have these routers, switch, and another firewall component, and I have to grab all the configurations from all of them, because the only configurations that I trust are the ones that are actually running on the production network. See, that's not good right there. And the thing is, I'm going to show you how we're going to do this in about 2 or 3 seconds. But right now, this is potentially hours till I get logged in, SSH, and all of those things, and then pull all the information back. Once I have the code extracted from these, well, then I'm going to build it. But wait a minute. If I have the code, don't I really have the build? Well, here's the deal. In NetDevOps, I actually need hardware or at least some virtual machine running that has these components on them so that I can write the code. So that means I need to go straight to testing. Now, I'm a big Simpsons fan. I hope you are. But I distinctly remember an episode when Patty hits an email to somewhere and sends an email, and this famous Cisco systems thing pops up. Not to poke fun at Cisco, mind you, but far from it. But the point is, right here, the test network must be identical to the production network. Too many times it's not. Often it's not. A lot of times the test network is whatever you tore out from other places, or maybe new stuff that's about to be installed. And if you want all the adjacent components as part of the test network, you're lucky if all those parts are there. And what's even worse, somebody else is already using the test network and you have to stand in line. That's just wrong. So we need to test the change before we deploy it. And we also have to test a rollback plan, because regrettably, sometimes it doesn't work. And this is also often just not done. And that's bad as well. So we have the build network. We have the build idea. We test it as best we can on a test network. We're at 4 of 10 here. So we write the release. So this is even worse. So what we're going to do now is we're going to collect all of these configurations of all the adjacent components that we need to make, and we store them on a laptop. So here's a pretty beat up laptop, but nevertheless, what's wrong with this? Kind of everything, because we're not safe from ransomware attacks. This isn't available to the entire network team. Is this tracking all the releases and all the rollbacks back since time? Not really. And is it tying directly to change management? Maybe, depending on the change management system you're using. And is it tracking the latest configuration of the entire? Probably not. I doubt it. Being in management for many, many years, I'm confident it's reasonably close, but hoping is not a strategy. And there's just nothing I really like about this picture or the current scenario. If you're running your network like this, and many of us do, so it comes time to deploy it. So using potentially the same laptop, we're going to SSH into components and push the config. Now, as I said, hoping is not a good strategy, but that's kind of what we're doing, because we went on a test network that wasn't exactly like the production network. Now we're pushing a change into it, and we're going to hope that it works. And if we did our homework, we at least have a form of an undo button where we can roll back if we need to. But rarely do I make a network change where I'm only changing one box. I'm usually changing a lot of them in order to deploy what is known as the atomic change. The atomic change, interesting, doesn't mean just one thing. It means all of the changes necessary to affect this one change, which could be on a number of components. And if the result is that it doesn't work, and now I have to roll it back, that again, going to be a manual effort as I push the rollback out to all these different components. There's got to be a way to do better than this. All right, let's go into the rollback. If there's no rollback strategy, that's really, really bad. And I personally believe this is the management's problem, not the staff. If you're allowing your staff to do this and you haven't given them the necessary tools that pretty much assures their success, then this is a management problem. There needs to be a way that the test network exactly matches the production network. And I already know with a high degree of confidence what's going to happen already. All right, so let's say we do pull it off and maybe we successfully roll back. Whatever the case, we are in the deploy phase at this point. Too often, it's the boss saying, "Didn't you test this?" Well, one of the battle cries is, yeah, we do have a test network. It's called production, right? That's a problem. And I still believe there's no reason to have a test system that isn't exactly like the production system. So this networking guy, most networking people that reported to me would not take this. That they would push back really fast. But the point is that there's a better way to manage your organization than this. Way better. All right. So then we get into the operation and monitor. So since we're kind of into what is DevOps, I have to tell you, we are out of the CI/CD pipeline. So the continuous integration and the continuous deployment phase, that's CI/CD right there. You could argue the coding is a big part of that, right? But look, here's what we want to have happen. If the code is submitted and it doesn't work, we find that out in test, and it's right straight back. It is the speed of iteration that is everything. Right now, for you guys to get from here to there in a lot of systems is hours. I'm going to turn that into seconds for you. That is like, didn't work, try this. Didn't work, try that. It's the speed of iteration, which is win fast, lose faster, is the goal here in ultimately getting this ready for release. Once we're ready for release, then that's the continuous deployment phase of CI/CD. So what then is operations? Well, that's just detecting broken stuff and reacting to it. I mean, things are just going to happen in the network, and that's what operation does, is I'm responsible for keeping it running. And if it's not running, figure out what it is and fix it. And it is very likely that if I find a config error or some problem in it, I should be able to go right back to here and be assured that I can deploy the fix way faster than just trying to fix it manually on a broken component. Lastly, the monitoring phase. So this is actually really straightforward. I'm looking for long-term error detection. That means, what are the current operational statistics? What is the norm that I would expect to see in the network, right? And once I've established that, then I'm going to look for any changes that are outside of normal parameters. Artificial intelligence is incredible right here. We're doing a lot of work in that as well, but that's outside of this discussion. So if that's the way we do it now, what would this look like if we deployed full blast NetDevOps? Well, there's a number of new components. The shining star, you thought I was going to circle that, right? The shining star is the production network. Your network, what is actually running at this moment, is the only source of truth. There it is. The thing is, if you rely on that as your source of truth, you're going to fail in NetDevOps. So what we need is somehow to get an exact replica of that production network into a change management system, into source code management, and perhaps in the NetBox, so that I can track exactly what's going on in the network. But here's the problem. There's constant changes to the network, and if it takes an hour or more to get each one of these components up into a source of truth, you will forever be fighting a battle and you will never win. You'll never have a source of truth that actually matches what's in the network. And quite frankly, at Alto 3 Research, we just got sick of it. Said this is crazy. And we have written, and it's part of all our courseware, the Alto 3 zero-touch provisioning system. So let me show you how that works, and then we're going to hit these various components here. Let's just engage it. Here we go. Step number 1. Before I do anything NetDevOps, I deploy Alto 3 zero-touch provisioning. And what's going to happen within 5 minutes, as you see a little gas gauge filling up here, NetBox and GitLab or GitHub, whatever you care to use at this point, is completely filled up with the entire network. Now, this isn't really true. It's not 5 minutes. It's more like 40, 50 seconds. So I added a little padding right there. This is blazing fast. And what just happened? Well, the NetBox now has all the network elements, the serial numbers, the firmware, all the cable connections, all logged in place, and the configuration stored with zero human error. Now, in the GitLab, if you're new to this scenario, ideally you're thinking, why do I need this? Because I see the configuration files here, and I also see them here, right? Well, developers don't like to work in NetBox because NetBox is only going to show you what is going on the network right now. It's not storing future configs. It doesn't know what happened in the past. That's not what it's for. That's why I call it the sock and knock box. That's the ultimate source of truth. I would say the displayer of truth of everything in your network. Help desk people would just love this. But if I'm going to make changes to the network, then I need to write the code to do so. And every time I make a change, I'm actually going to plan out 2 things, not 1. The implementation change code and the rollback code. And I'm going to do that for every element that I may be changing in the network in order to implement some sort of a change. That then becomes the change that I'm going to wait for to deploy when the change window opens. So the first thing I need to make all this magic happen is fully configured NetBox and GitLab system. With all that in place, let's start the NetDevOps approach and see how that works. Now, remember, we have the production system that we absolutely positively know is replicated in these 2 components. And we start with our first step, which is planning. Here's how I would do it. Well, here's how we do it, right? Is we take the portion of the network that we know we want to change and transfer it into Cisco Modeling Labs. 10 seconds. As fast as you hit the enter key, it's there. It's incredible, right? And then I'm just going to use this tool to actually do the screen grab of what it is I'm going to look at. And I can sketch right on the paper. For those of you who are really good with Cisco Modeling Labs, just make the change right there. But at this point, what you know for a fact is that the production network and your test network are identical. They are exactly the same. Now, you're probably not interested in the whole network. If you have thousands of endpoints, you only maybe need 20 or 30 of them, so you can select a certain diameter or a portion of the network where you actually want to pull into Cisco Modeling Labs, and you do the planning. Step one done. So I now have an exact replica that's diagrammed. I can make the changes in the posts for management approval if I'm going to do that. Done with planning. Next step. Write the code. Well, okay. The next step would be actually to throw that away, unless I'm just going to go from planning right to code writing. That can happen. And I'm going to pull in the portion of the production network that I want to write code within. It only takes seconds. So honestly, if I have something up here, I'm just going to delete it and just bring it right back in again. It's just too fast, which is interesting because it just changes the way you think, right? Once that's done, and I have the network perfectly replicated, I didn't, if I'm working on that switch or something like that, I didn't have to copy this stuff into there, right? I know that it's there already. The whole configuration, everything is there. And I just make the changes that I need to. And I'm going to test it. And I'm also going to test the rollback plan. I'm not going to wait till these steps. I'm the developer. I'm going to make sure, at least reasonably sure, that this is going to work, right? Now, not quite done. The next step then would be to say, all right, I've coded the config changes, and I'm going to store that in ultimately it's going to be a enumerated release. So I'm going to save the change code that implements the change. Then I'm also going to save the rollback code. In our system, we teach our students, you have to write both of these. You don't get to just write the implementation change. You have to write both of them. So now we have all the changes. Maybe the changes involved a few components right here. It doesn't matter. The system will be happy with that. But at this point, we have submitted code. All right. So put the check mark up here on the code, and we're ready to move into the build and test phase. This is the continuous integration part. Well, the build phase is almost like cheating, right? I'm ready to go into build, which means whatever CMI is loaded, throw it away, right? And load whatever the portion of the network is that I'm going to test. So network replicated on CML, that's seconds. Then the next step is, okay, I have to test it. No. Wait a minute. I tested it back here when I wrote the code, right? No, that's not the CIC. I know you did, but that doesn't count. We're going to do this again. And the reason we're going to do this again is because I'm going to pull a replica network into CML. And I'm going to take this code that you told me that it was going to work, and I'm going to run it on there. And then I'm going to run the test scripts. I'm going to see if it does work. This is seconds, guys. This doesn't take long. And quite frankly, I would have the staff do this manual for a little while, but at Alta 3 Research, we've long scripted this. We don't do this manual anymore. But I think if you're implementing this in your organization, you'd want to run this manually. And then the rollback code, run that as well. So this manual thing only takes a minute or two. It is pretty crazy fast because all the hard work is done with zero-touch provisioning. All right. So testing passes, because if it doesn't, you know what? That's okay. That's why we did this. Then it's going right back to whoever wrote the code. You don't fix it. You're the tester at this point. That goes back to whoever wrote the code, said it failed. Try again. And this is where you want to keep your work and know when you get to this stage, what actually goes into production is highly likely to just work. And now the CI of CI/CD is now done. So we move then to the release. So the release phase is actually done on GitLab or GitHub if you prefer. But let me give a sort of a plug for GitLab and why we prefer it. There are some customers that will have an air-gapped network, which means they're not going to let you use GitHub or some cloud-based thing. GitLab allows you to run your own server for the price of, it's free, it's open source software, and you would run that against your particular network, right? So, and by the way, you can track the issues and everything else. It'll work just like the one that's in the public domain. So our favorite tool here is GitLab, in case you're wondering. So what I want to do now is say, look, I got past the testing and build phases. So I'm actually going to mark this release as an atomic change, which means whatever change code I have in here and whatever rollback code I have here is now marked and ready for deployment in the next change window. A little more about that change window in a moment. So we're ready for the second part of the CI/CD, and this has to wait till the change window appears. So let's bring in the deploy phase. Now, at this stage, a timer fires, which if you're new at this, I wouldn't fire a timer. I would have network staff initiate the deployment. It's one line, it's one prompt in zero-touch provisioning, push the change. A change using Ansible is how our system works. In order to deploy that will take seconds. It will be, in fact, it'll be such a short period of time till everything's provisioned and your test scripts are run, right? It's crazy fast. You certainly, whatever the change window is, unless people are giving you 20 or 30-second change windows, which even then is plenty, right? Now, this is, you know, how do you want to play this? At this point, you have to decide, well, what's going to happen? If you followed what we teach you, the likelihood of success is extremely high. But I've been in this business for a really long time. It doesn't always work, right? So sometimes it just will fail. Okay, we're ready for that. Number one, we will initiate the rollback. And we've tested it, so confidence is high as it's going to work. And listen to me now. To go to the boss and say, the deployment failed. It's not working. We're going to roll it back. And you deploy it 20 seconds, 30 seconds later, whatever, you're rolling it back. In less than a minute, the whole event is over. The opinion of your skills changed forever. And you failed, right? Like, how could you get kudos for failing? It's because you did it fast, right? But the likelihood of that happening is very low. But here's what I want to teach you. So listen up. This is a trick that the developers have known for a long time. Every time they fail, here's what they do. And we need to adopt this. This is great thinking. It usually comes from poor testing. So what in testing didn't I check that I should have in order to make sure this doesn't happen? And then you just implement that in your testing practice, which, by the way, is now a thing. It is a scripted and controlled thing. This isn't going to happen again because you never want to make the same testing mistake twice. You'd say, well, how many failures do I have to go through until I get to this point? Well, first of all, the likelihood of a fail is very low. It doesn't happen very often. But if it does, you won't make that mistake anymore. That's for sure. That's what's so cool about this. So, by the way, next thing I need to warn you about. Oh, you've got your change window and you're making a change on maybe that firewall device there. And you think you see the problem. Don't do it. Don't do it. I know you want to hop into that box and just change it because that's the way you've always done it. You have to stop thinking like that. Right back into code, build, test, release. Now, the reason you're not used to thinking like this is you don't know that you can get from there to there in 30 seconds once you get good at this. You don't know that. And you have to start thinking like that, right? And said, okay, I have the new release. I proved it. I verified it on the test network. I've actually implemented whatever the changes are to actually whether the monitoring systems are in order to make sure this doesn't happen again. And then I push the change. Now, some organizations will say, you failed, that's it. The next window comes up, whatever, and that's fine too. So it depends on your management, right? But what's really interesting for the DevOps guys is they have failed so many times that their track record of getting all the way to here and actually having a failure that anyone's going to recognize is so low, like particularly with Kubernetes. You can get to all the way to this point, have a container tank, systems will tear it out, replace it with a new system before anybody even knows. I predict that day is coming for networking people, but it's not here right now. We have to earn that kind of trust. But ultimately, pass or fail, the deployment phase is done. And we're ready to start the process again, whatever the other change may be in the network. So if you like this, you think, wow, how do I do this in my network? Well, let me walk you through some training classes that I would strongly recommend. Number one, this one is cool. It's for the business analytical people, 2 days. And by the way, the lecture and hands-on, you'll actually do all those things that I've just shown you. You'll do all of them. Build networks, restore networks. It's just that we don't make you be a CCNA, but honestly, I'm expecting some very skilled networking people to probably take this class. But you know why you're taking it? Because you want to do this. What's it going to cost in effort and manpower? What is the risk and reward that I'm going to have to pony up in order to do this? Like what you see, looks really great. And now you can go to management with a spreadsheet and say, here's what it's going to cost. Let's do it. Then the next step would be implementing NetDevOps. So at this point, you've got nothing. You don't have the NetDevOps and you want to deploy a zero-touch system of your own. That's what this is. Now, the implementing NetDevOps does include the operations component. That's why it's 5 days. So we'll show you how to implement it and also how to operate it. But as time goes on, once you have the system fully implemented and it just works, trust me, it just works. Then you get into the operations phase where it's like, I don't need to know how to implement it anymore. I just want to take my CCNAs, CCNPs, IEs, and I want to have them run my network. And I want them to follow the NetDevOps approach. And of course, we can do that in 3 days. We're not really concerned with implementing it. Not done yet. One more. I guarantee this is going to happen at some point down the road when you see how straightforward and attainable this is. It's like shockingly cool. You're going to want to make feature changes. Someone's going to show some programming ability and actually want to do that stuff. So in that particular case, you need to understand system internals. You want to write custom integration software to make the system do stuff that it doesn't do right now. That is perfectly within your skill set and ability to do that, because there's something I need to tell you right now. We just go back one time to make absolutely crystal clear. NetBox, open source. There's no charge for that. GitLab, open source. No charge for that. The Alta 3 zero-touch provisioning system. All the tools, the finished code that does all this magic included in the courseware. No additional charge for that. And of course, you have a production network, which is crazy expensive. The only component in here that actually does have any expense at all is the Cisco Modeling Labs component. When you take the class, each one of you will get a CML voucher in order to take the class and build everything. So you'll actually be running on a live CML platform. Any additional budgetary information, that sort of thing, that's what this class is for. Okay, I have been ignoring the questions. I see that none have come in. This would be a good time if you want to start chatting some questions in there that we could load that up. That would be great, guys.
There are a couple questions actually in the Q&A.
I didn't see them. What are they?
No, you're good. One says, what is the tech stack used for DevOps?
What is the tech
Stack.
Yeah, sure. Okay. Well, in DevOps itself, that's incredibly varied, right? But the networking portion, all of the magic were the components I've shown, plus Python and Ansible. So, and we do it all with Python, Ansible. We explain some of the code internals, but we're expecting most students attending this class want to learn how to implement it and make it work. And I honestly, I do think this is way too often where these kind of things go sideways, and this doesn't happen here. As a networker, I don't really want to write code if I can help it. I would rather use code that already does what I need it to do. That's why the zero touch provisioning system right here is a completely finished product, right? But the stack, Python and Ansible, both of those are open source. So as far as software goes, this is incredibly affordable. Any other questions?
The other one in the Q&A is the cost of the classes you were just talking about.
Okay, so this is where the salespeople really get angry with me when I answer that question. So you would actually want to reach out to your tech. And in fact, right now, I think we're probably responding in the text with an answer of who you should reach in order to contact Sunset and book this training.
Yep,
But,
I can put a link in there for you. Tristan was the one who asked that. Okay, a couple more questions are coming in. You have Cisco Modeling Labs in your list, which I believe mostly supports Cisco devices. If you have a multi-vendor network, what do you recommend?
I would still use Cisco. Well, okay, it depends how much other network stuff you have to support. The reason that I really like Cisco Modeling Labs is because we've written the code to, well, what we do is we actually yank it right straight out of there and write straight into Cisco Modeling Labs. And you actually can do your testing that way. If you're fortunate enough to have real hardware, we'll just push it right into the real hardware. This isn't hard for us to do, right? But Cisco Modeling Labs, if you haven't tried it, I would urge you. And bear in mind that Cisco Modeling Labs will support like Arista or something like that. You can run that in here. That's not impossible to do. So guys, it is possible to do all of the work on real hardware. It's just that you miss out on so much of the rapid testing. You want to go from here to there with zero effort copying SSH configs around. You don't want to do that. And that's where Cisco Modeling Labs really helps out. That being said, if you want to discuss that more, then we need to have a one-on-one. Get me involved with your salesperson, and we'll do some sales engineering right on the spot, and we'll sort that out. There are other ways to do this as well. Other questions?
Yep, and this might go with the answer that you just gave, but is this Cisco specific? We're moving towards Arista with Ansible/AVD.
So here's the thing. We run Arista in our network as well. All my Cisco knowledge just transferred right straight over to Arista. We know our system works just fine in Arista. So it's the missing component would be Cisco Modeling Labs. But even if I couldn't have Cisco Modeling Labs, to have my entire network captured exactly as it exists in GitLab and in NetBox, which I don't care what the stuff is down below. Arista looks so much like Cisco anyhow. As far as configuration goes, it's not really all that hard to do this anyhow. Arista also has some really powerful Ansible tools. One of the issues I believe in Arista and the way they're handling this is they have all these really nice tools, and I get the feeling like I'm a future homeowner and I want a house, which is what I'm proposing here, like a fully built NetDevOps house. But what I get is, here's a hammer and a saw and a chisel. Here's some power tools. And here's a really nice stack of lumber. Go ahead and build your own house. And that's not what networking people want to hear. They want to say, look, I want the house built and I want that integration just like you saw with Cisco, but I want to do that with Arista. I mean, the Alta 3 research, that's what we do. We do that stuff for a living, right? It's just that right now the talk is specifically Cisco. So rolling in Arista, I mean, it's not, I don't know, it's quite like boil an egg for us, but it's in that hunt. It's not going to be hard. It's just kind of what we do. Other questions?
Yeah, and this is kind of along the same lines. What are your solutions for non-Cisco devices? I don't believe that CML is supported for these platforms.
No. Well, it wouldn't. I would argue it's not really. It doesn't really work well on any of the platforms. Here's the problem, right? How do I get my production network into CML? Even Cisco doesn't have a clean answer for that. They want one, and when I showed them our system, they want it bad, right? And I don't blame them. But it's just that I'm from the world. I feel the pain, and this has been going on long enough. We're a DevOps company applying this. The NetDevOps was a natural thing for us. So I believe that you're going to find is that Cisco Modeling Labs may be able to handle your situation just fine. I would encourage you, contact your salesperson, bring us in. There's no charge for this, and we'll talk about sales engineering opportunity there. See if we can't sort that out for you. Might just be a little bit of custom code that is completely within reach. Other questions?
That's it for right now. If there's any other questions, we will answer them at the end.
Okay, Tracy has just sent a link out to all of you, and it is humorously amusing. Gophers crawled. You see the link right here. So here's what you want to do before I turn it back to the rest of the team. If you go to that link, the first thing you'll see is this. Now, hold on. Before you do this, the reason you're doing this is you want to try a hands-on lab trial. Hey, I would like to see what this environment looks like that I could actually sort of test a few ideas. Now, there'll be no Cisco Modeling Labs in there. That is licensed software. So, but what you will see will be the automation components in order to do NetBox and get an idea of the lay of the land. Once you supply your alias, whatever login you care to use, and your email, you'll see a screen that looks like this. Click on the content. Now, if you see no resources available, that's because we didn't click fast enough to assign a cloud resource to you, but we're pretty fast at that. So that is normal behavior. It will clear in a very short period of time, and it'll wind up looking like this. So what you will see once you actually get into this system is the live network, and you'll be able to watch the intro video. I strongly urge, watch that video. So if you hit this little hamburger, that little hamburger will be over here, of course, but when you click it, this opens, and you want to click on the first lecture and watch that video. That shows you how to run all of this. It's a very clear video that describes running the system. And then what we have is, as you work down through this, it's just a sampling of some of the random labs that are taken out of the Implementing NetDevOps course, right? And you get a sense of that. Now, the real course goes on for like 80 labs. This is just a small portion of it, just to give you an idea of the lay of the land and basically how that works. One last thing, maybe if we could pass that link out as well. We have staff manning in whereby.com/Alta3 Labs. If you elect to, hey, I'm actually going to do this lab, but I would like some help, is there going to be someone like a teacher there that can actually help me if I get stuck in some of these labs? Of course. So you would want to use this link, not right now, but when you want to try some of that hands-on stuff, that would be a very convenient place to go. It's low pressure. People are just standing by that will answer your questions. These are teachers that are very good and patient at helping you out along the way. I believe that's it. If there aren't any additional questions, I'm going to turn it back to you, I think, Eden.
Yep, there is one that came in.
Yep.
What about EVE-NG instead of CML?
Okay. We have not integrated into those. It certainly doesn't scare us, that's for sure. Bear in mind, Cisco really wanted this, so we were gently nudged in that direction. But we're Alta3 Research, we're not Cisco Systems, so integrating this into any number of test platforms that's the kind of stuff we do for a living. So not a problem. So if you're wondering why didn't I talk about that here, because it really is, this is definitely has the Cisco slant on it.
Perfect, thank you. And thank you guys for being here today with us. We do have one more slide for you after this. Stuart, do you have that slide? Perfect. So we do have some open enrollment classes coming up from the list that Stuart was talking about a little bit earlier. And we do have a promotion for you to join these classes. Next slide, please. So if you just use code NDO 2024 at checkout, you'll get 20% off all 4 of these classes. So I'll put that link to explore those in the chat. The code does expire at the end of the month, but you can use the code for dates after April. So you just have to use the code by the end of the month, but it applies to any dates that we have on our website. They are all guaranteed to run. There's no chance of us canceling last minute on you, so you don't have to worry about that. But these are great in-depth trainings that tie into what Stuart was talking about today. So that is all we have for you. If there are any other questions, you can throw them in the Q&A. We'll be around for a couple more minutes. But thank you so much for being here. Thank you, Stuart, for presenting. It was a great webinar, and we hope to see you in one of our next webinars.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.